Okay, so back to using robotics and electronics in class. Because a robot or a microbit, for example, are absolutely awesome. They are very motivating to build something in the real world. You will notice this when you will use this in class. But there are a few downsides of working with materials like this, and I also want to make you aware of these. Because when you build something with materials like robots, microbits, or other sort of hardware, the problem can lay in either this, the hardware, or in the program that's written for it. So we just saw the thermometer example. For example, it says 21 degrees. But what if it's not 21 degrees outside? Then what is wrong? So imagine I put the thermometer in the fridge. I press A and it still says 21 degrees. Well, is then the thermometer broken, or does the program not work correctly? So the problem can be many things. There might be even more problems occurring when you use the dice we built earlier, on which we had to place these wires. Remember, it had these tiny holes or parts we had to connect the wires to? It's all pretty delicate and small to read. A mistake is made really easily in this. You will notice that students will become frustrated by things like these. There are simply just more things involved that can go wrong. And it's difficult for them then to move forward with their projects. If it really doesn't work, it isn't as easy as in Scratch to just, go back a few blocks again and rebuild it again step by step. Imagine you're having a long program, a long piece of code. You need to break this down step by step for the microbit, for example. So the lead time is very long. Keep this in mind, because this has a lot to do with tracing back what the problem is. So reading code back to see what the problem is much harder when you also use hardware. In Scratch, you can have the code right next to the output. So the screen will show you what you've coded. This is on the same screen and the same location. With the robot, the distance is much longer. This distance can be physically, that you program something and so you program something here on your computer and then you have to walk outside, for example, to test it there. But also the distance in time. So the length of how long something takes before you can review your output. Like what we did with the microbit, you build it, you write the code, then you have to download it on a device, wait until the download is ready, etc. Only after that I can see whether my code is working. So this is what I've noticed with the kids, that working with hardware results in them ending on a sort of plateau. They go forward a little bit, but they stay longer in these lower levels of Piaget because they simply can't practice enough with how to trace their own problems, because it is so difficult to do in a hardware environment. So I do advise you to only use things such as the microbit only for the higher grades. Think of the last class of primary school or the first classes of high school, but really not earlier. This also depends, of course, a little bit whether students already followed programming courses in class, but just be careful with it. So again, please be aware of that this can be challenging. You don't want to start working with a microbit, experience a lot of problems with this, which might result in scaring students off. That they think, oh, technique is super difficult. Once you get the hang of it and you explain everything well, it will be fine, of course, and it is super cool to do.